Hello students, good morning to all. So students, today we will continue thermodynamics. We will do some more basic terms of the thermodynamics today. First of all, we will discuss about thermodynamic equilibrium. What do you mean by the thermodynamic equilibrium? Students, at a given state, all properties of a system have fixed values. Thus, if value of even one property change, the system state change to a different one. For example, students, if I am talking about water, you know very well, at room temperature, and at atmospheric pressure, its standard state is liquid. Even if we change one condition here, like if we change temperature, means if we provide some extra heat, if we provide to this one, then students, you know very well, its state can be changed. After absorbing heat energy, it can convert into the vapors. Means here in standard state, it exists in liquid state. But if we are doing change in any one of the property, here we are changing the temperature by giving heat. So it can be converted into the vapors. Its states can be changed. Clear or not? Yes. Means at a given state, a system have all property fixed. Okay, but if any one of the property we change, if any one of the condition we change, then property state also can be changed. Clear? In a system that is in equilibrium, no changes in the value of property occur when it is isolated from its surrounding. What do you mean by this? Students, for example, if I am taking hot water in a bottle, in thermos flask I am taking, you know very well, thermos flask has adiabatic walls. And what do you mean by the adiabatic walls? Adiabatic walls are those. Here transfer of heat does not take place. Means total change in heat is 0. Clear or not? So here, if we are taking isolated system, means neither energy or heat we can say, because heat is also form of the energy. If energy is not entering from surrounding to system, neither system to surrounding, means here del H is equal to 0. Adiabatic process it is. Okay, so what will happen here? Here it is hot water. So you know very well, some water will exist in liquid state because it is hot. So some vapors will also be here. Okay. So here, if they are both liquid and vapors, they are in equilibrium. They are in equilibrium. What do you mean by this? Means this liquid, because it is hot, so it is going to convert into vapors. But students, here it is closed. So this lid, this cover of the container, what will happen? It will apply pressure on these vapors. It will apply pressure on these vapors, and these vapors further condense and they further convert into the liquids. Means here both processes are going on. One, liquid is converting into the vapors, as well as vapor are converting into the liquids. Clear or not? If both the processes are going to be with same rate, if this here liquid to vapor, I can take it forward. Means here reaction in forward direction and in backward direction. If in both direction it is proceeding at same extent, then it is known as equilibrium. It is known as the equilibrium. Clear or not? So student, what does mean? If here any matter exists in two phases, and if in both phases it is in equilibrium, it is in equilibrium. When it may be? When neither we are giving heat from surrounding to system, or nor system to surrounding, then it may happen. Clear or not? Means they are in equilibrium. Clear to you or not? Yes. Then students, when the temperature is same throughout the entire system, we consider the system to be in thermal equilibrium. Means if in entire system, let us consider this is the system and this one is surrounding. Okay. If temperature in entire system, temperature of each and every particle present in this is same. Here temperature also same, here also. Means at entire system, if temperature is same, then it is known as in thermal equilibrium. In thermal equilibrium. It is clear to you or not? Yes. Then when there is no change in pressure at any point of the system, we consider the system to be the mechanical equilibrium. Means if there is no change in pressure, here also pressure same, here also pressure same, and pressure is not going to change according to the time. At any instant of the time, if pressure is not going to be changed, means it is known as in equilibrium. And what type of equilibrium it is? It is the mechanical equilibrium. Clear to you or not? Yes. Then students, when the chemical composition of a system does not vary with time, we consider the system to be in chemical equilibrium. If overall composition remain constant, there is no change in the composition of the system. Okay, with time. For example, student, what happen if we do any reaction? For example, if we are having reactant A and with time it is going to convert into the product B. Clear or not? So here what will happen? At time 0, at time 0 means when reaction has not been started. So at that, this reactant will be maximum, at maximum, but because reaction has not been started yet, means product is 0. At that time, product is 0. Now, at time T1, means reaction has started. What does take place? Here, this reactant start to convert into the product. Start to convert into the product. Means this reactant start will decrease it according to the time. With time, reactant will decrease because it is going to convert into the product. But product will increase it. Product will increase it. Clear or not? But if an entire system composition remains constant, it is not changing with time, then it is known as the chemical equilibrium. Then it is known as the chemical equilibrium. Clear or not? Yes. So next one is phase equilibrium. Phase equilibrium in a two-phase system. Here, two phases. Like one may be solid, second one may be liquid. Okay, one may be liquid, other may be gases also. One may be solid, other may be gases. Means here two phases are compulsory. Phase equilibrium in a two-phase system is when mass of each phase reaches at the equilibrium level. Mass of each phase means if we are talking about evaporation, so here liquid is converting into the vapors in gaseous. So two phases are there. One is liquid phase and second one is the gaseous phase. If mass of both phases is equal, then it is known as phase equilibrium. Then it is known as phase equilibrium. Clear or not? In case of sublimation, you know very well, solid convert into the gases. Solid convert into the gases. So when mass of both phase is equal, then it is known as the further phase equilibrium. Clear to you or not? Yes. So students, if a thermodynamic system is said to be in thermodynamic equilibrium, if it is in chemical equilibrium, mechanical equilibrium, and thermal equilibrium, and phase equilibrium also. Means if it is showing all type of the equilibrium, thermal equilibrium, it is chemical equilibrium, mechanical equilibrium, and phase equilibrium. So we can say that it is thermodynamically equilibrium. It is thermodynamically equilibrium. Clear to you or not? Any doubt in this topic? Yes. Then students, our next term is the enthalpy. What do you mean by the enthalpy? Enthalpy is the measurement of energy in thermodynamic system. Means enthalpy is the energy. It is the measurement of energy. The quantity of the enthalpy equal to total heat content of a system equivalent to the system's internal energy plus the product of the volume and pressure. What do you mean by this? Enthalpy. It is denoted by H. It is denoted by H. Clear or not? It is sum of the internal energy. If I talk about the system, let us consider some liquid is present in this. Students, a number of type of energy may be present in a system. Like these particles may be collide to each other. They may or may not collide. Let us consider they are in liquid state and some are in gaseous state here. Some are in gaseous state here. Okay. So they may be collide with each other. If they are colliding, means they are in motion. If they are in motion, then kinetic energy may be there. Kinetic energy may be there. Energy possessed by an object due to its motion is known as the kinetic energy. Clear or not? If some are fixing here, okay, then their potential energy also. Clear? If we do some work on that, means it is absorbing some amount of energy, other things, means some heat if it is absorbing, if it is releasing, then minus we can do, means total amount of energy which are presenting inside the system is known as internal energy. Internal energy. Total amount of energy present in a system is known as the internal energy, and it can be denoted by the E. It can be denoted by the E. Clear or not? So enthalpy is the quantity total heat content. Enthalpy is the total heat content. Means it is sum of the internal energy present in the system. Internal energy present in the system. Plus, if we apply some pressure on that, then its volume decreases. Okay. Pressure and volume both are inversely proportional. Okay. So plus product of the pressure and volume. This total heat, sum of the internal energy present in a system plus product of the pressure and volume is known as the enthalpy. It is known as the enthalpy. It is clear to you or not? Okay, so the enthalpy H equal to the sum of the internal energy, total energy present in a system. It may be sum of all energy present in a system. Clear or not? And the product of the pressure P and volume V of the system. It is known as the enthalpy. Any doubt in this? Yes. Next one is the entropy. Entropy is a thermodynamic quantity whose values depends on the physical state or condition of a system. In other words, we can say that it is a thermodynamic function used to measure randomness or the disorders. Entropy measurement of the randomness. Randomness or disorder. Means the state of the system, particle how much get moved freely. This is the entropy. Randomness, disorders, their freedom, is known as the entropy. For example, students, if I talk about the solid, if I talk about solid, here particles are closely packed. Liquid particles have some space between them, and in case of gases, particles have number of means they are loosely bound. They are loosely bound. In case of solid, minimum space is there. Minimum space is there. If they want to move freely, it will be difficult for that. They cannot move freely. They cannot move freely. Why? Because they are closely packed. They are not having any more space for moving. Clear or not? So here randomness, disorder, freedom is minimum. Is minimum. Means they have minimum entropy. They have minimum entropy. Here liquid have some space between them. As compared to the solid, they have more space. So they can move as more as compared to the solid particles. So they have more. Can move. Okay. But if I talk about the gaseous, number of space they have between them. So they can move freely. They can move freely. And you know very well freedom, randomness, measurement of this is known as the entropy. So here entropy of the gases is maximum than solid. Okay, and entropy it is denoted by the S. Okay, students, today we have discussed just basic things, only definition of enthalpy and entropy. Okay, in next class we will discuss about the what type of property it is. It is extensive, intensive. It is denoted by which letter? Okay, what is the mathematical expression for that? What is unit for that? We will discuss all things. Clear or not? So I hope all things are clear to you. So thank you. Have a nice day.